The objective of the analysis was primarily focused on flood control and disaster management associated. The project brief was also to analyze net zero water use as well as managing flooding situations by controlling flows so that it does not flow out of the property. The workflow in the project was divided in two parts. These are two-dimensional transient modeling of flooding on terrain obtained from digital elevation data. This digital elevation data was sourced from SRTM 30 GIS data sources, as well as some drone survey conducted at. The second part of the workflow was with respect to the development of one-dimensional network model of all catchments, drains, junctions, pumps, and all the storage available on the site. The first part, where a watershed was computed through GIS techniques for the region, indicated 2200 square kilometer as observation area. The significance of this watershed was that all the rain that falls in these areas shall be typically trapped in the area itself. Therefore, either it will be absorbed in the earth or remain stored to create flood-like situation. In the planar region, with range of hills and mountains on the northern and the western sides, the risk of flooding remains a concern. So here's the drainage model, and in this drainage model you can see that various nodes and various drains network is being represented in a one-dimensional way. On the left side, top left side, you can see the legend, and in this legend various magnitudes are represented by different colors. Now this is the simulation which is running, and in this simulation you can see transient data with respect to time. So transient is with respect to time. It shows that what would happen in November, what would happen in December when the rain is happening in some way or the other way. You can see that the colors are changing. It means that the channels are flooding and working normally. In this specific graph, you can see whether the channels, what kind of levels are there at various nodes, like in tanks and in channels, etc. When the backflow is happening in the drainage, when the flooding is expected. Site survey and development of tentative site drawings, division of catchments into sub-catchments, ponds, wells, pumps, drain network, junctions, and parameter related to these components were built into the model. The purpose of the whole exercise was to get optimum pond sizes synchronized with the pump capacities that results in no flooding conditions even in torrential rain situations. Another design objective was to enable the drain's self-cleaning velocities. This was done in the due process. To achieve all the above objectives, the whole network model of the project was analyzed through numbers of iterations. For the case of 1065 mm annual rainfall, which is torrential rain, we followed a methodology wherein at the first we found that the clarifier flooded, and for reducing the to improve upon the clarifier flooding, we have to reduce the pump sizes, which led to the flooding of the pond. That indicated us to increase the pond sizes in the next iteration. Even after increasing the pond sizes, backflow in the drainage was happening. Therefore, we increased the pond sizes further, and that led to an accepted network of the same. For the in the similar way, for 75 average rainfall, we had benchmarked the complete drainage network on this specific rain, and we found that it was not okay, and again the clarifier flooded. Therefore, we had to reduce the pump sizes which are coming from the pond, which led to an accepted design. As a conclusion, if we compare the demand, which is 3000 meter cube per day for the paper division water use, the torrential rain throughout the year would only suffice for 56 days. And on an if we design it for an average rainfall of 785 mm per year, then only 33 days are there which are available for full water use without purchasing it from outside. So the cost of making the system which can hold water for 56 days, provided that there is a torrential rain, uh, versus the cost of the system uh, making it for average rainfall would only yield to 33 days of availability. So this is just a comparison to enable the decision makers to take an informed decision whether they would like to pump the water out as soon as the flood happens during the torrential rain, or they want to store it, because that can happen say once in 5 years or 10 years when the torrential rain happens. So this is one of the very important aspects that would go into the decision making process for making the system effective.